Right, we're back on the old camera. There's a reason for that. Continuity. I started making a video, say, I don't know, 6 months ago, 8 months, a while ago, a long time ago, and I never finished it. I didn't finish it because I was really busy just doing other things, and I couldn't find a good time to wrap it up. So I hadn't discovered the speed of just making a video on an iPhone. I've got a list to make sure I cover all of these bases. In the video I did a lot of explaining about this milling machine that I've got by the side of me, but I've kind of covered that in a few old ones. What I thought I'd do is still make use of the video, edit that stuff out. You can go back and watch some other videos if you want to know a bit more about this milling machine, I guess. One bit that was in that video that wasn't in anything else I've done recently is I've got a company now that I do this under called Group A Fabrication, so you can go away and find the Instagram of that. It's a nice professional front end, whereas I guess these videos are a bit more ad hoc and personal, but I haven't really figured out a nice way of doing it that will satisfy the two. So here we go, let's just crack on. Yeah, so I'm going to re-edit it. There's a nice product in there, it's quite good, some of you might like it. There's a lot of work involved, so it's not cheap, but it's nice. What do I have to do now? Okay, so everyone hold tight, we're going to go back in time and I'm going to start explaining the bit of Group A car that I had and the fact that I needed to replicate it somehow, but the original process was quite difficult. This is a Reineck oil takeoff of a real Reineck engine. It's not a Group A engine, it's a GT engine, but they all had these on. There were slight differences. Some of these didn't have the oil temperature sensor here, but other than that they're all identical. They all had these 1/8 MPT takeoffs. What it gives you is just a really nice way to bolt up to the factory bolts, run an oil cooler and have your oil filter there. The only issue with this is it was die cast, which would be mega money to tool considering how many I'd probably be able to retail of these. So I looked at it and thought, okay, that's probably a good challenge. Let's try and machine something that is almost identical to this and does the same job with my company on it. And that's when I thought, maybe I should make a video of this. So here we are, I'm doing a batch of 8, 3 are spoken for, and I've just finished the last one, Op 1. That's why that one was in the 4th when you looked in the mill. Why don't we go over there, I can show you what I did for Op 1, and then we can start setting up Op 2. So we start with a big block of 6082 T6, and this cycle runs for about 2 hours to get all the material off. First of all, it runs with a 50mm face mill. It's got 90-degree teeth, so I use it like an end mill, and it gets a lot off very quickly. And then have to go and do the details, so the kind of really nice surface finish, all the threads in it, they do take a long time. So it's 2 hours on the machine to do this. So I've done 8 of those now, this is just finished. Now I need to move across this work holding device into the 0 point plate over here, and I can start running Op 2. The nice thing about these is they've got torques on all of them, even the clamping load on here, so you can use a torque wrench rather than just trying to feel it. It makes it really good and repeatable, especially when you've got jaws on things, because all jaws lift, so the amount of lift you get can be proportional to the amount of torque that you put through the vice grips. So having that repeatability is just really good for doing batches. Not that I do many batches, right, but it's good for even going from prototype to production. So next step is just to measure the height of that, put it in the offsets, and then we can run the cycle. To measure the height, I've got a Hymer 3D probe, which is okay. It's not as good as a proper Renishaw job. It's pretty accurate, but I have had issues with them and they do need consistent recalibration. So we'll swap that out and manually put it in. I don't like leaving it in the mill either. It is IP65, but I just don't trust it. So how this works is you take the measurement here, and then I know the length of this tool, and then I've also taken a measurement to where I set all of my tool heights, and I set all of my tool heights off a 1, 2, 3 block, which is just there. What you end up putting in the controller is the difference in height between the top of this 1, 2, 3 block and wherever you specify your datum to be. And this is one of the things that's worth keeping an eye on, because it does tend to drift. I don't know if it's the gauge, I don't know if it's repeatability of this tool and this long setup in the spindle, but for the extra 1 minute it takes to reference that every important setup, it's worth doing. That's up 2 done. You can see we can get the oil in here. It's done the lovely thread where your filter will spin on, face this off, and then yeah, it's quite a lot of work to pocket out all of that. So the next stage is we need to not hold it on this surface. You can see there's little teeth marks across here from the vise that I use. So what you do for that is you make a pair of soft jaws. Essentially, the soft jaws are just an inverse of the piece that you're trying to hold. So in CAD you import some soft jaw blanks that you design, you import your model with the soft jaws a certain distance apart and you can subtract it, but then you do need to do some extra modelling to make some clearances. So in the corners here, for example, I've got the extra radius so it can go right up tight to it. Then what I do is I clamp a parallel in here so it's under tension and the right torque is on this, mill it all out, and then it fits perfectly in there. And the idea is it will hold it without causing any damage to the surface finish, so your finished part will be lovely. Right, I'll get that clamped in, start the final operation, and we'll look at the finished part together. Welcome back to present day. This is where I stopped. So the only thing that I didn't cover was kind of the assembly of the final product and the fact that it went to the anodizers and came back. Now, it went to the anodizers and I got the whole batch done in clear, so they are as per the originals. I have thought about doing some kind of funky custom colours. Maybe if people actually buy them in the future, this is something that I could do, some like limited edition runs. I don't know, getting ahead of myself. Let's just see if anyone likes these. What I have had done is I got these AN fittings custom made. They're the same size as the originals and they're anodised in exactly the same red as the originals, which is pretty nice. I assemble everything here and it's assembled with proper Nissan oil filter studs. Both of these are torqued up and Loctite thread sealant is used, so they are as good as possible. Because I'm assembling them here and I want everything to be super high quality, I also 3D printed some of these. Now these are socket inserts. I can put that in there, I can use an actual torque wrench and not damage any of the anodising at all and get all of them consistently torqued up and marked. C'est fini. So this is an example of one. Fittings are all torqued up, everything is sealed properly. You kind of get that in some nice wax paper with a label in a box. 2 1/8 MPT for temperature and pressure. If you want to read it on the core, there's a temperature coming back out of the oil cooler, so you can data log pre and post. Completely compatible with the standard RB as per the Reineck one, so you just take the mode iron off, bolt that straight on, job done. These are for race cars or track cars, you know, but if you want to chuck it on a road car, you can put something like a Mocal thermostatic switch in line, so your warm up is still relatively good, you know, and it lets you run a nice big oil cooler with high flow oil cooler lines. We're in the future now, but when I was doing this I was only a few items into my CNC programming experience, and I've come back to review it after being busy with a load of other work, and I think they're stunning. If anyone wants to know the horrible numbers, I think it's about £280 plus VAT for one of those, and then obviously shipping on top of that to wherever you may live. I'll put an email address in the description. All you need to do is email that with some details and I can get an invoice over to you. How's that? Not bad. Like it, subscribe to it, email me if you want any of those. I've only got a few on the shelf, but if there's any sort of inertia behind it, and as soon as I get some more mill time I will make a load more of them. Good to see you again. The next video will be another kind of vloggy what I've been doing this week video. It will be shot on the phone. Sorry if the sound and visuals isn't quite as good. Let me know if you really prefer this, or if you can't really tell the difference between this and an iPhone. Be interesting to know, wouldn't it? We all like that kind of data.